Welcome to the CEN Show, a platform where we learn from the world community. I'm your host, Rashaki Maskani, and on the panel this evening we have Professor Rahh, Ernest McBride Jr., Brother DX is here. DX haven't been around in a while, but he's here. One of our team members in Atlanta. And brother Ahi. All right. We got our team member, Mr. Hood, with TED Talk today. So he's going to take over, and I'm going to be watching and listening. All right, Brotherhood, welcome, man. Do your thing.
Greetings. Thank you guys. Appreciate it. I'm happy to be back. Peace and blessing to everybody on this call and everyone who will watch this on a replay. I'm really excited and honored today to be able to share this valuable information. And this is a very interesting topic. I've been doing some research for the last 9 months on some of this information, and I'm excited to share it with you today. So what I wanted to do before I get started is show you a little clip just to kind of set the foundation of where we're going. It's kind of like my reaction. I gave this this talk about a month ago, and so I wanted to react to some of the content, and then I updated some of the content, and just to give just to lay the groundwork. And I am going to be dropping some science tonight, so I'm gonna try to break it down a little bit. And if something is, you know, if a light bulb goes off for some of you guys, and you can break it down a little more for some of the audience. My aim tonight is to basically help others understand really the seriousness of what we're dealing with some of this artificial intelligence and what we learned in 2025.
Hey everyone, Mr. Hood here. Get ready, because the pace of AI innovation is accelerating, and we're breaking down everything you need to know right now.
Welcome to Tech Talk with Mr. Hood. I am Larry Hood, and today is AI Update, what we learned in 2025, and what it means right now. This isn't a hype recap. We're breaking down what's real, what's next, and what skills and decisions actually matter. We'll talk politics, the global AI race, jobs, chips, and even a real case study of an AI-designed drug in trials. Let's jump in. First, I want to start with a question. Quick question. If an AI can sound empathetic, does that mean that it's empathetic? It does not matter. And does that matter for the future we're building? Hold that thought. Let's set the stage.
Away.
Okay, now, before I get started, this gentleman here is the guy who runs Anthropic. He's a president and CEO. This is the World Economic Forum, and he's talking to the guy who started Gemini, Google DeepMind. And I want you to listen to what they're actually talking about when you're talking about taking the human out the loop and how it relates to some of the sciences and some of the things that we're going to talk about tonight.
From when the model is doing most, maybe all of what SWEs do end to end. And then it's a question of how fast does that loop close? Not every part of that loop is something that can be sped up by AI, right? There's like chips, there's manufacture of chips, there's training time for the model. So it's, I think there's a lot of uncertainty. It's easy to see how this could take a few years. It's very hard for me to see how it could take longer than that. Yeah. But if I had to guess, I would guess that this goes faster than people imagine, and that key element of code and increasingly research going faster than we imagine, that's going to be the key driver. It's really hard to predict, again, how much that exponential is going to speed us up.
But you, Demis, were a little more cautious last year. You said a 50% chance of a system that can exhibit all the cognitive capabilities humans can by the end of the decade. Mm-hmm. Clearly in coding, as Dario says, it's been remarkable. Mm. What is your sense of, do you stand by your prediction? Yes. And what's changed in the past year?
Yeah, look, I think I'm still on the same kind of timeline. I think there has been remarkable progress, but I think some areas of kind of engineering work, coding, also you could say mathematics, are a little bit easier to see how they would be automated. partly because they're verifiable what the output is. Some areas of natural science are much harder to do than that. You won't necessarily know if the chemical compound you've built or this prediction about physics is correct. You may have to test it experimentally, and that will all take longer. So I also think there are some missing capabilities at the moment in terms of like not just solving existing conjectures or existing problems, but actually coming up with the question in the first place or coming up with the theory or the hypothesis. I think that's much, much harder, and I think that's the highest level of scientific creativity. And it's not clear. I think we will have those systems, so I don't think it's impossible, but I think there may be one or two missing ingredients. It remains to be seen how, first of all, can this self-improvement loop that we're all working on actually close without a human in the loop? I think there are also risks to that kind of system, by the way, which we should discuss, and I'm sure we will. But but that could speed things up if that kind of system does work.
We'll get to the risks in a minute, but one other change, I think, of the past year has been a kind of change in the pecking order of the race, if you will.
Okay, what do we?
All right, so let me go ahead and switch gears here a little bit. So what she mentioned in that, what he mentioned in that was taking a human out of the loop, right? So what I wanted to really discuss tonight is some of the concepts and some of the things that have happened in 2025 that we really a lot of people really don't really know about. And as far as myself, mass surveillance, that's one of the things that we definitely need to understand. And I want to just give you guys a brief, breakdown of who I am and where I've been and what I do. So I do teach at Compton Unified at an early college program, and I'm proud to say we are one of the top 2%. We're ranked in the top 2% of schools in the nation, and I just wanted to say that because that's a really, hard thing to do, and I've been there since we started. And I also have a website, bustechacademy.net, and I do have a certification in Adobe General AI Foundations and a CT instructor. And also, my goal is to, keep the YouTube channel going, playlist on the AI Institute to talk about topics and break some of these concepts down. You can check that out here. And then here are some agents that I created on OpenAI's platform. One in particular, I have hundreds of users on it, called the AP CSP Guru, because I teach a computer science class at early college. And I created this agent several months ago when OpenAI was actually last year, when OpenAI opened the platform to be able to create your custom agents. So I know a little bit about creating agents, coding, all of this. And you can customize a GPT to do whatever you want to do. And so I wanted to share that just so you guys can access that. I got about 4 of them I'm working on. One of them, the APCSP Guru, is one that anybody can use. You can use it to break down some topics, code, or it kind of will explain things for people who are trying to learn. All right, so this slide I got from a researcher in Australia, and it's something that talks to AI versus human intelligence. And so what I started doing when I was really going deep with research on artificial intelligence, I like the fact that this guy was basically just putting out a lot of research from different companies and what they were doing. And so what this shows is AI versus human intelligence. So back in 2022, Microsoft did a study that looked at, the IQ. You see how ChatGPT-4 had an IQ score of 155, and then you have a gifted child at 170. And so what they were doing was testing the large language models and looking at different things. So the paper and the research that I'm talking about here examines moral sensitivity in intelligent children. It looks at parallels about ethical abilities in something called ASI, which stands for artificial superintelligence. And so by highlighting how advanced intellect fosters goodness, it offers reassurance. Smarter systems can lean towards kindness and fairness, easing our fears about AI evolution. That's what Dr. Thompson said. But for me, it seems to me that there's a lot of research that is coming out or that's being introduced that's trying to say that if an AI is super intelligent, that it's going to be more ethical. And so I'll beg to differ. And as you're going to see tonight, It's not really just because an AI is smarter that it means it's going to be more ethical. And so the move towards ASI, what I'm talking about tonight is super intelligence, okay? And what they're trying to do to say that AIs are super intelligent, and we're not there yet, but we're going to talk about some topics. And this is just a picture of me when I was doing a generative AI certification for Adobe. Adobe has a platform and a certification that you can get using some of their tools. A lot of these companies have their own different AI platforms. And so what I'm going to do tonight is I'm going to go into a lot of deep areas dealing with artificial intelligence, and not just talking about making videos and writing papers. Okay, we're gonna look at actually what's happening with generative AI and how that's really affecting our future, really. And so, as far as what I'm talking about with the future of the industry, we have a lot of stuff happening right now. AI is shifting from experimentation to large-scale deployment across all sectors. The media narratives focus on hype versus durable value, jobs, skill, and regulation. So the next decade, in my opinion, will be shaped by the compute policy and how fast organizations can adapt. And one of the things that was kind of interesting to me is that when I did a talk, I guess last year when I was here, maybe about 9 months ago, a lot of the information that I put about 9 months ago on this topic, they're starting to talk about in the mainstream media. And so it's kind of interesting. So I wanted to just kind of go there. And so this is some of the research that I found about uh, what they were doing and how machines have empathy. And what they were doing was testing some information on a Reddit platform. And basically, they did a research study, and tried to say that ChatGPT has more empathy than a doctor, which I thought was very interesting. And so this is kind of a breakdown of that, and you can look at the link there to the research. And so what was that research? What was it? Okay, I'm going to go ahead and read the abstract here because I do have all of the references, all of the works cited that you can all go back and do some research on. But let me tell you about this research here. So basically, in this cross-sectional study, it was basically a non-identifiable database of questions from a public social media forum. And what it was doing was it was used to randomly draw 195 exchanges in October 2022 where a verified physician responded to a public question about health or healthcare. And so what they did was chatbot responses were generated by entering an original question into a fresh session without prior questions having been asked in the session. So the original question, along with an anonymized, randomly ordered physician and chatbot responses, were evaluated by a team of licensed healthcare professionals. And so what they did was they evaluated what the AI said about health, the questions from the public, and what the actual doctor answered with the question. Okay. And so from that, they came out with this study, and used it to say that AIs are more empathetic than a doctor. Okay. So from 195 exchanges, and then they put out this research. So that's kind of a little bit of a background on what I'm talking about here. When you're talking about research and putting out content, and then there's a lot of bias here because what happened with that research, it was found out that it was a biased study because the organization that put it out was affiliated with Microsoft, and Microsoft is I guess has a large share of OpenAI. So you understand the research is biased because the company is associated with this kind of research. And so what they did with this is trying to determine morality and make it seem as if an AI has morals or how they can measure morality. Okay. And so I'm like, how are they going to measure morality? And so what I did some research, and I realized that they're using something called a behavioral defining issues test. Okay, and so I'm going to read this. So a behavioral defining issues test looks at three dilemmas: the Heinz dilemma, newspaper, and then something called an escape prisoner. And so for each dilemma, participants were asked to examine whether a presented behavioral option to address the dilemma is morally appropriate or inappropriate. They were then presented with 8 items per dilemma, asking the moral, philosophical rationale supporting their decision. For each item, 3 rationale options were presented. Each of the 3 options corresponded to one of the schemas or moral reasoning proposed by the Neo-Kohlbergian model of moral development. Personal interests, maintaining norms, post-conventional schemas. The participants were requested to choose the most important rationale. And so if you don't know what Heinz dilemma is, I'm going to just kind of break that down for you real quick. Heinz dilemma is something that is used in psychology. It's kind of like questions that you ask to gauge morality with someone. So like for instance, one of the questions is if I have a wife that's sick and I need to get some medicine, but I can't afford it, should I steal it to save my wife or should I not? And so some of these kind of questions are looking at how you would answer that question. Okay. And so this is a formula. And so basically when you're dealing with AI, it's not human like. It's basically just looking at calculations, statistics, and measuring. So this is how you measure the behavioral issues test. It's a probability. Okay. And so if you look at this formula, it's P equals number of selected post-conventional options divided by 24 times 100. But all that is number of selected post-conventional options. All that is how would an adult make the decision on that? Okay. And the problem with this is years ago that had to do with children in an educational setting to teach them morality. Okay. It was four components that was used for humans that were children of, like I guess K-8 type of students. And so this is something that was created by someone named Lawrence Kohlberg, and you can look this up. And so this is what they're doing, trying to apply morality and test an AI using this measurement. And so what is morality measurement? It has 4 components: moral sensitivity, ethical sensitivity, the ability to interpret a situation as an ethical problem, recognizing who is affected and how. Moral judgment, ethical reasoning, evaluating different courses of action and determining the most ethical choice using ethical principles. Number 3, moral motivation, ethical intention, prioritizing the morality ideal outcome over the competing values like personal gain or social pressure. And number 4 is moral character, ethical implementation. And what this is just possessing the perseverance, the courage, the skills to actually carry out the intended ethical action in the challenging situations. So in a nutshell, the key idea here is ethical behavior requires all 4 components. Failure at any stage can prevent a moral outcome, even if someone knows the right thing to do. So this is why I say it's not really something that you want to use to gauge morality with an AI. But this is what is being introduced and tested on some of these platforms. So I want to share that. And this is where we're talking about, super intelligence. Okay. We're already at generative intelligence, but we're talking about super intelligence. How can an AI have morality? I don't believe that it can. It's a machine. Now, what is my goal? My goal for this presentation is just to simplify and educate people on AI and push the conversation forward to emerging technology. I want to push the conversation forward because there's a lot of stuff that's happening that is not really in the mainstream. It's not really kind of breaking the surface of what's really going on, what's really happening. And so what I wanted to do in 2025, we learned a lot about a lot of different things. And some of the stuff is so advanced that we need to have more conversations about this stuff and engage others to learn. So I'm going to explain my research findings, current revolutionary progress in AI intelligence, and the move towards superintelligence and what that is and what that is not. So AI bubble or durable transformation. So there's a big debate over whether current investment resembles a bubble. Later is warned about irrational spending, but long-term productivity gains is still expected. The key question is which business models survive and which ones, you know, deliver deliver real return on investment. Okay, so there's a lot of spending happening. A lot of data centers are being introduced. A lot, and so a lot of people are, you know, are being disrupted in their jobs. But what we're seeing is there's a lot of stuff that's happening, but a lot of people just need to understand we need to retool. Okay, we need to reskill, and we need to understand what areas are being affected and how we can use that going forward. So on this slide, what I wanted to do was show you something that I got to kind of break down some of the things when we're talking about ASI, super intelligence. And so when you talk about super intelligence, let's look at the things in orange. These are, we're at the precipice of ASI. We're not fully there yet, but these are some of the things that AI can do or has done. You talk about creating new elements, going beyond silicon. We're talking about mental wellness. They're using AI for mental wellness, physical healing, energy discovery, energy harnessing. And this would be all the stuff here you're looking at the top in orange are looking at things that could potentially happen versus that are happening. Now, I would consider this phase one. And we're not really here with all of these things. And you see optimized birth, brain interface. There is a brain interface, but it's not something that's really working properly. Using AI to fix your mental health, not something that is really happening. And then you're looking at phase two, which is governance and economic transformation. And this is something that's happening across the world. There's different countries are using it. And then you have, physical world integration. And we'll look at this more, but one of the places I got this was from Dr. Thompson. You do have AI being used in regional governments, and AI is trying to be introduced in our government, and we'll talk about that in the future slide. So I want to kind of just give you a breakdown here. This slide is really representing what we're talking about with super intelligence. Now, one of the things that I wanted to talk about before I really jump into this is the lithium ion batteries and the global supply chain. And why am I talking about that? Because there's a lot of things that are happening in the world, and a lot of these things are geopolitical. Because in the 1980s, the discovery of lithium cobalt oxide enables today's lithium ion batteries powering phones, electronic vehicles. But the key ingredient come from geopolitical concentrated regions, creating supply risk and choke points. And this is from the U.S. Geological Survey. And so one of the things that we got to pay attention to, and why some of these things are happening in different parts of the world, is because of critical materials that are pushing this revolution with technology and AI. They're all using these materials, and this is what's going to lead to some future slides that I'm going to talk about when you talk about generative AI dealing with materials. So when you talk about critical materials, the Democratic Republic of Congo dominates cobalt. 76% still of the world mined output comes from the Democratic Republic of Congo. 10% of it comes from Indonesia. And then China, it leads in refined cobalt. And so it's often used as an intermediate material imported from the Democratic Republic of Congo. And so lithium, there's major mines out there in Australia, Chile, China, Argentina, Zimbabwe. And for the U.S., most of our lithium imports are coming from all over the world, but you're also looking at Chile, Argentina, and about 47%. So this is a really important slide I wanted to show you guys because this is something that is really important. And when you talk about chips, we're going to talk about chips in the future on these future slides, is you need sand, you need cobalt, you need all these different things to make some of this hardware. And so I wanted to pause real quick. Anybody have any topics or want to share anything about this or have anything they want to point out about anything I've said so far? I just want to take a quick little
Did you
temperature
want
check.
me? Did you want me to go to the panel?
Yeah. If anybody I'm gonna take a quick little pause right now. Just if anybody have anything to say about what I've said so far.
Yeah, but let me go to each person and see if they want to say something.
Okay, definitely. Most
All
definitely.
right, Professor Rahh?
Yeah. How you doing, Brother Hood?
Oh, I'm doing great.
Good to see you. See, I'm lost in technology. I'm be honest with you. I understand AI is, being used in all kind of capacities. Robots and everything. But where I'm trying to get is that you're trying to see if it has empathy, and then you said coding and take the human out of the loop. What do you mean?
So what's happening is with some of these AIs, they can code without having a human uh, intervene in making things. So you have basically a robot that actually is coding all types of things. And you're talking about material science, you're talking about creating new drugs, you're talking about making software applications, you're talking about cybersecurity. And so a lot of these things that are being created, they have risks. And so what I see happening is a lot of these companies, some of the bigger platforms, they're trying to take the human out of the loop to kind of save time, but we should always have a human in the loop. And so what I'm trying to say is that just because the platform is smarter doesn't mean it's more empathetic. And so what I'm seeing with my research is there's a lot of research that's being introduced that is trying to soften the blow and make us believe, or a lot of us believe, that AI can be empathetic, can be ethical. And I beg to differ because it's not a machine. It's just a series of statistical formulas are used in a biased type of way, in a nefarious kind of way. So that's kind of what I wanted to share because what I see is a lot of this research is being introduced to make us believe that it can be empathetic, and I disagree.
Now, you said you have to get this material to make chips.
Yes.
And
Yeah, you
so
can.
are
Yes.
you saying that the chips that they're making, them, it takes on its own uh, 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 behavior and activity so that it produces its own intelligence uh,
Yes.
from the standpoint like a brain?
Yes. Yes. So what's happening now is there is a new series of chips, computer chips, that have
Yeah,
been
but who's
introduced.
making the chips? That's my point.
Intel.
Okay.
Intel. Yeah, Intel. And I'm going to talk about that in some upcoming slides.
All
So
right.
what's
Okay.
happening? Yeah, I'm going to talk about that in upcoming slides. I'm going to go real deep on that.
All right. I got
Go
a
ahead.
couple more questions.
Yeah, go right ahead.
Okay. When you say AP, CSP guru, what do you mean?
So AP Guru stands for Advanced Placement Computer Science Principles Guru. So what I did was I created an agent, an AI agent, basically my own version of ChatGPT that is specifically geared toward answering questions about computer science and programming. You could ask it questions, you could put code in it, and it's going to give you more detailed answers. Because I teach a computer science class, and I wanted to have something that was geared towards students that can learn, anybody who wanted to learn how to learn about some basic topics or learn about coding or different things related to AI. Because there's there's a I mean, there's a free version of ChatGPT, then there's a paid version, and then there's customized versions of AI that you can use. And so what I'll do at the end of the slide, I'll go into my ChatGPT platform and I'll show you how anybody who has a paid version of ChatGPT, you can go in and access all of these different agents that different people have made to do certain things, more specific things that go beyond what ChatGPT has as a base level platform.
Well, what about this so-called, this concept of artificial superintelligence, ASI?
Yes. So artificial superintelligence has to do with the next phase that they're trying to say that AI is going to reach. And I don't think we're quite there yet because there's a lot of things that are, I would say, that are unknown. And that's kind of that's why I wanted to show the video of the guy from Gemini, because you cannot take an AI out the loop. If an AI is making drugs, we don't know what the side effects or the risks are. And what I'm going to do is talk about a drug that was totally generated with AI that's in phase 3 clinical trials. It's the first one, and we're going to go into that. But this is what I see happening. Because when you talk about generative AI, you're talking about a lot of risk. So AI is being used now to create drugs, create materials, create different things that are dealing with the table of elements. And so AI can create new types of things that have never existed before. And so this is the problem that we're looking at when you talk about having AI do everything on its own. There has to be some type of guardrails when you're talking about generative chemistry and making, yeah. And so that's kind of what I wanted to talk about. We're talking about ASI. This is talking about super intelligence.
Yeah.
Because you can't have a moral AI, but that's what some of the research that's being introduced for some of these platforms is. And so that's kind of what I wanted to stress on that. But great question. Mm-hmm. And so on this slide, it's basically when you talk about a global race in the world with AI, it's a race, global race in geopolitics. US is number 1, China's number 2, and the EU is number 3. Okay, and they're all treating AI as a strategic infrastructure. Okay, there's a mass race of everybody trying to have the best AI. Okay, and so a lot of the cities to reshape the landscape, companies need to choose research talent and compute access. What is compute access? That's just having enough horsepower to run all of your calculations on your platform. And so this has to do with, having a data warehouse, a data center that's kind of like doing all these things. So you don't have a bottleneck. And so that's what's happening with this. That's why a lot of these data centers are being introduced. And there's a lot of pushback too. A lot of people are becoming more aware of what's happening.
Yeah, and as I close, and other people guys, but they're having struggles with places that want to build these AI power centers, and people are against it because it draws so much power and will take up so much water and so much energy to create these factories or these companies that produce this. So
yes.
I'll get into that. I mean, you can respond to it because there's some pushback on them expanding. Yeah.
Yeah, and I'm glad to see it. I'm glad to see it because it's kind of out of control. The spending's out of control. It's more of a profit-driven idea. So when you look at China and you look at the EU, China focuses on rapid deployment to boost industry and state capability, and the EU is prioritizing human-centric approach. Basically, they're having some rules and guardrails, and so basically, there's not enough regulatory rules around this technology. It's taken off so fast that there's just not enough rules around this innovation. And so,
Yeah, that's why
and
people think it's a weaponization of AI.
yeah,
It is a weapon.
yes, it is being used as a weapon. And that brings me to something I just found out about recently was OpenAI has one of these weapons and they won't even introduce it because they say it's so dangerous that it can basically be used to hack into any company because it has a cybersecurity aspect that's kind of causes a lot of risks. And so they're not introducing it. But
Mm.
it kind of has to do with all these companies trying to compete with each other. And so what they're saying is that this one is pretty dangerous, and so they haven't introduced it yet. I think it's called Mystic or something like that. But you can kind of do the research on it. But they have one that they're not really introducing yet. So job skills in the AI labor market shock.
Hey,
So media,
hey,
go ahead. You got one?
let's get to the other people, see if they have anything, and then we go back
Okay.
to there.
Okay, sounds
Uh,
good.
hey, Ernest, you're on mute.
You guys still there?
Uh, he's
Okay.
on mute. Let me go to
Okay.
Ernest. I'll come back to you later. DX,
Yeah, greetings.
Greetings.
Man, I was on the when you was talking about how AI is using psychology to um, render decisions, right? The I was wondering like if because like this sounds like familiar like with blockchain, right? Because I know you're
Okay.
familiar with blockchain and how it works. Like things go through
Yes.
one system then to the next, and
Right.
then if something
Yeah.
wrong, okay, so in
Yeah.
our in our community, like person to person, like it's already like a psychological environment that is set up to draw an emotional response to our traumas. So do you think that by utilizing what information is already, because everything's on the internet, we put in our feelings, our emotions, posting our personal information,
Right.
businesses, everybody, our phones, children, jobs, everything is all going in. Just like when the internet started, it was like, wow, this information, we putting it in there. So same
Right.
thing with this super AI from a psychological perspective. I could actually see where it could calculate a certain response based on like even for us because we can calculate like I think our environment is set up, my book is kind of is based on the whole situation about our
Yeah.
environment is set up to a calculated response. So I think it
Exactly.
may just come to that
Yes,
if
I
it hasn't
agree.
already.
Yeah. Yeah. That's what's happening. That's what's happening. And what you're talking about is edge AI. Edge AI is basically using the data that's local on your phone, that's local on your laptop, that's local on your PC. There's an engine that's being created and a basically an AI engine on your local machine on your phone. And so when I'm talking about these neural chips, these NPUs on your
Mhm.
computer chips, now you have an AI engine that is saving and storing all of this information on your local device that could be queried and pulled by different sources if you're not aware about that it's even happening. And then when you talk about a corporate environment where you have maybe a business who is, I'll explain it to you this way. Think
Mhm.
about think about how everything is ran, with the computer chip, okay? And the computer chip is embedded in your device, right? But
Mhm.
imagine a computer chip having a little bit of memory that's set aside to keep a little AI engine on your phone. And then it's able to store all your images, some of the things, some of the nuances, uh, some of the thought experiments about your buying behavior, what things that trigger you. Yeah, and you have a and you what you realize is you have a basically a way of mining all types of personal information from people's devices that they use every day.
Right. All right. One last question, real quick, while we on this. Because I had a little bit of information about how ICE was using a program that was created by Peltar or somebody like that, or whatever the
Yeah,
company is.
Palantir,
Yeah.
I'm familiar.
And,
Yes.
they in this program apparently uses an AI app, like what you talking about, like the super AI thing, criminal or not. And that's what they
Yes.
were using to lock people up.
Yeah. Yeah. It's called predictive policing.
Yeah, that. Yeah, yep.
Yeah. Yeah.
So
Yeah.
they
Who's more
already
like?
using it.
Yeah, they're already doing it. Yeah, they're already doing it. I mean, you really what the logic and the algorithm behind that is the AI is going and looking. It's looking for the likelihood of a crime having a likelihood of a crime occurring or will occur. Okay, and so it's looking for that potential. So when you have social media, you literally have people posting things, posting on there with their guns, uh their situations, different things, and then so you have AIs that just looking at the images, the videos, and then you can have an AI just generate a report. Okay, well, these profiles here, you may likelihood of maybe a crime occur. And then if you somebody who's, you know, doing all the extras, showing your money, your bundles, cash everywhere, you setting yourself up for a lot of issues. And I'm sad to say that I do have a relative that got caught up in that. You know what I mean? He was young, dumb, gang banging on the internet, showing everything. He didn't care, and he got caught up, and that was years ago before we heard about all these different tools. So now you got AIs that's doing, so it's yeah, predictive policing, and that's AI coming in.
Thank you.
Great topic. Yes.
All right. Let's go to Ahim. Brother Ahim.
Yes, brother, it's very interesting. Um, most of the people like you agree that there is a tremendous upside to this AI. It's just, I mean, you can't see what's really coming. That's like 10 years ago trying to predict what we are now. But the people see a tremendous upside. But uh, most of the people who study this also see a apocalyptic part of this.
Yes.
People losing control, being discarded. Um, AI not only studies the information that you put in to try and be more efficient, it studies itself. So in essence, it's writing its own code. So um, that's a particular type of growth that can't be controlled. And uh, people are kind of like throwing darts in the fog, uh, trying to get some type of idea of where this is going and how to control it. But um, it's the two side. I mean, it's not as bad as like the atomic bomb, where it's wasn't a whole lot of upside to it. It does have a lot up from diagnosis with doctors and even AI being a team where you can have um, one, two, three, four, five AIs acting like a team in different areas to solve problems. But
Yes.
this thing about humans being discarded and an apocalyptic future is really got me kind of shook. because a lot of you guys are talking about 10, 20 years, maybe even sooner, that this possibility could take root. And I just want you to discuss that a little bit.
Exactly, definitely.
Okay.
Yeah, totally. I totally understand what you're saying. I appreciate the question. And that is the reason why I wanted to give this topic, because when you talk about taking humans out the loop, yeah, AI can do some things, but you have to understand that there's always a way of giving an AI different prompts, and you could change the way the AI takes on a different persona. So, for instance, you can have an AI that is making calculations, right, and making determinations on different things. But if you're the person who has inside information on how this AI was created, you can prompt the AI based on keywords and things that you're already aware of, and have your AI take on a different persona. That persona could be good or bad. And so that's why there's a big concern about that, about not taking the humans out the loop, especially when you're dealing with physics and generative chemistry. Okay, because then you have an AI that's creating pharmaceuticals that could potentially be hazardous, and like what I'm going to talk about in these upcoming slides, one that was really created by China, but it went all the way through to the phase 3, and so it's ready for that last step to be introduced. But it's kind of serious because there's no cure for what it was trying to do, and so they're trying to introduce a cure for something that a lot of people need, but it's like, what are the dangers there? You know what I mean? And so if we just rely on it, that there's a real danger there. So we need more people who are aware of how some of this technology works, and not just uh, listen to the media mainstream to try to soften the blow on how it's trustworthy, it's smart, it has a high IQ. No, no, no. There's a lot of other aspects to it. And so, yeah, just because it can do a lot of things that humans can do, we can't just let an AI robot go, willy nilly in the world and make all these decisions where uh, human values uh, are important. Okay, and so that's what an AI does not have values, and so that's the distinction there. An AI is just looking at numbers and statistics, and so that's
But
the important.
but AI doesn't always tell the truth either.
That is correct. That is correct. It can hallucinate, and if you never done any if you ever done any research on some of these platforms, it definitely can hallucinate. And so that's what I want people to understand. And a lot of people are getting dinged by it. You got lawyers being sanctioned, doctors are using it. You got a lot of clinical trials. People are trying to introduce new things, but it can hallucinate, and you got to understand that. And so that's why reskilling and continuous learning become really, really core economic priorities. It's you can use it for research and help you learn things, but you also got to understand some of the more powerful things of being able how to use these tools to be more productive, and to create other economic opportunities for yourself, in your businesses and whatnot. And so that's the part that I want to stress tonight, because when you talk about super intelligence, this is what they're trying to do. Okay. So DX mentioned, hey, you have the AI. When I'm talking about edge AI and what's happening, everybody has a phone, right? And so if you're putting in all the information, your device is creating a profile of you. And if you have a new NPU chip on your device, and more, you can have your AI generating a profile for you. And if it's generative, it could create different aspects to share things with you, or to do different things. Maybe share things that you may not want to share. Okay. And so that's kind of what I wanted to do, is creating This is where we're talking about edge AI, like the actual engine is on your device or your phone. And some of these things are embedded in the chip, so you don't really have access to them. You're going to have a certain software to see. And so, and if a company is shipping out millions of these devices, it could potentially have a backdoor to pictures and everything else that you're thinking and talking about. And now, if you have a company and you're trying to like use it for cybersecurity, then that's going to be great because you can have an AI that sits on all these machines and it would be able to stop some of the vulnerabilities because it's looking at the chip. The chip is already on the device, so that would help in that regard. But in other aspects, it could be dangerous because you don't know really what's on your phone or your device. And so this is when we talk about, autonomous agents that coordinate workflows and not just chatbots. Okay. So when I said that I made an agent on ChatGPT, this is where we're talking about agentic AI. So where you have an AI that's an agent, you have companies now that can create an agent for the job that you do. So you can have like a clone of yourself, like a digital coworker. Okay, organizations pilot AI as a digital coworker for drafting, coding, and analysis. This raises questions about oversight, reliability, and human and AI collaboration models. So this is something that's happening right now. And so you can have a digital coworker. Now, on this slide, what I wanted to do was just kind of like just basically share what kind of inspired me to go into this create this presentation. I attended last November the Future Forum, the use of AI to advance healthcare. The keynote speaker was the president of California State University Dominguez Hills, Dr. Thomas Barham, and he brought in some very, very important people that are working in this space. A lot of topics we discussed was AI-driven healthcare innovation. I learned about a lot of different platforms that are being used in healthcare, which was amazing to me. Some of them are being used to, um, you know, listen to people, make determinations for doctors. It's being introduced in the social welfare space to have an AI assess whether a person could be housed or not by a series of questions and making decisions. Ethics, we talked about collaboration for systematic change. It was a great uh, future forum. I learned a lot about different things going on in healthcare. And one of the things that I want to share with you guys right now is something that is being used in healthcare. It's a platform called Ambient Scribe. And let me tell you what it is. Ambient Scribe is a platform that is being used in healthcare to help doctors save time. So what it does is when you're sitting in the doctor's office, it listens to everything that the doctor is saying to you as a patient. And what it does is it starts administrative paperwork based on what the conversation is. So the doctor doesn't have to fill out a bunch of forms. So it creates notes, it creates electronic health records, um, diagnosis and code suggestions. I mean, it can help administratively, but also there are problems here. Now, when I found out about this, I was like, wow. And so I reached out to my sister who works in the mental health field. And I said, hey, sis, what's going on in your space with healthcare, mental health care about, chat bots that listen to what you're saying to your clients? And she was like, yeah, there's something that they're testing now called Maury AI, like Maury Povich, Mauri, Maury AI. And what it does, she's been testing it, and what it does, it listens to what she's saying, and then it makes recommendations on her patient. And she told me, she was like, yeah, She said, you know what? I looked at what it did and what it said. It was telling me that my patient was suicidal, that he was violent, and all these things. He said that my patient was none of these things. But based on it listening, it gave all these recommendations and diagnosis and code suggestions for her patient. That she is, she's the person in the middle. But think about it. If you have something that's doing that and somebody is using some type of chatbot that's listening, you could have a potential where an AI is making some erroneous decisions, locking people up, uh, doing all kinds of things based on, whatever code is in that system. So it can be used as a weapon that way. So it's being introduced, ambient scribe being used in healthcare. So I wanted to share that with you. Compute chips and the infrastructure bottleneck. So GPU stands for graphical programming unit and data center capacity. So basically what's happening is they're trying to create these data centers because they want to have enough, infrastructure to keep growing. And like Professor Ross said, a lot of communities now are pushing back. And what you're going to notice is a lot of these new data centers are in areas in kind of rural areas where there's not a lot of people, but are close to water and different things. So there's a lot of massive investment in AI chips and energy efficient data centers. And so the control of advanced fabrication and supply chains becomes a source of strategic power. So these data centers are ways of them trying to harness strategic power in this space of AI. So this leads me to what I'm going to talk about with chips. So these are computer chips. And so before I continue, I had to talk about Mark Dean. When I gave this topic, it was during Black History Month. A lot of people don't even know who Mark Dean is, but Mark Dean was somebody. He was a computer scientist, the chief engineer at IBM in the 1980s. He led the team that created the first IBM personal computer, the PC. This is the guy who created the PC, and he later developed the first gigahertz CPU chip in 1999. This is the guy that made it possible for us to have color monitors. If some of you are old enough to remember the first computers that were invented, it was kind of just the green monochrome screen. But his research and his work at IBM is what led to the first gigahertz processor. So I wanted to share that with you guys, some of you who've never heard of him, but he's still living. He's kind of like a living legend right now, Mark Dean. So I wanted to share that with you guys. So when we're talking about chips, this is where we're at. The traditional CPU is on the left, and the newer modern AI chips are on the right. This is what's happening. You're talking about a different infrastructure, a different architect type. And so the modern chips now are something called SoC, and that's software on the chip. And so what they did was they changed the architecture. And so those of you who know anything about hardware, you know how you got to have the processor, the graphics, then you got to have the memory card, separate memory. Well, now what's being introduced with some of these AI chips is they're putting more memory into the chip, which allows data to be stored on the chip, and you'll never see that data because that's embedded in the chip. Okay, and so this is when we're talking about building our edge AI or building a local AI engine that is storing information that you may not ever see. And so when we talk about chips, it's Intel. They're in the third generation of these chips. It's called the Series 3. Okay. And this was introduced, the Series 3 was introduced, I think, in January of this year. And this is what it looks like. You have a different type of computer chip. You have a graphics tile. It's kind of basically a tile-based infrastructure. it was basically before just one big slab of silicon. Now you have it broken down in different areas. You see how it says graphics? That's a part of the chip that's just dealing with all the graphics. Then you have SoC, that's the software on the chip. And then you have the input and output tile, and then you have the compute chip. And so what this does is having these kind of chips, it's going to allow your computer to have longer battery life. Also to store information. And if you're doing like high speed editing, gaming and different things like that, then it may help with with your performance of the computer. And also, if you're a company, a big organization, and you have a lot of these chips in, you could build a cybersecurity platform that could query these chips and the data on these chips and surveil that way by just using the NPUs that are on the chips. And so the first one was introduced in 2023. This is called the Meteor Lake chip. Okay, like I say, graphics tile is for 3D performance, so you have better 3D performance. And then the SoC tile is for power, and then you have the compute for CPU. So basically, what these chips allow you to do is do more faster. So it gives you better graphics, about 76% higher with the Series 3 chip. It's superior power, efficiency, and very good performance for gaming and content creation. But if you're using a Linux computer, it's not going to matter. Okay, so it's kind of, I would say with Intel, it's more geared towards kind of Windows machines, or if you're using a phone that has some kind of NPU chip or in some kind of AI. So you got to have some kind of AI software as well as the chip so they can interface. But this is just to show you that we are in our third iteration of these types of chips right now. And so here we go. We got a breakdown of kind of what these chips look like. Panther Lake is the code name for the Core Ultra Series 3, unveiled at Computer Expo in 2026, designed for high performance, AI-driven laptops. These chips are the first client CPUs built on the 18A node, featuring up to 16 cores. So that's just tech talk for basically your computer has a lot of power. Okay, when you talk about cores, think of a core as an engine. Okay, and so the more cores you have, the more power you're gonna have. And you see here on the left how it says NPU 5. That's a neural processing unit. So that's basically a little memory that's building an engine on the computer that has this chip. So it's a different architecture. And so if we're talking about the PC, those of you who've ever, deal with hardware or built a computer, this is the one on the right would be the thing in the middle, the little square in the middle. That's how you can recognize some of the older chips. They're more square. Okay, so this motherboard is a older chip type, but the one on the left, you see how it's a more rectangular kind of chip. So that's the thing that gets hot in your machine. That's the engine. Your CPU is the engine that powers your computer. Okay, and so with these new chips, you have more memory embedded, and you have support. You see all these other little chips here? You have support chips that can work with the the CPU here. Okay, so you can have other memory, smaller chips that can support here. And you would never see any of the data on this unless you had some kind of specialized software or system to pull this kind of data. I mean, literally, these chips could store screenshots of every single image that you have on your machine. Now, in terms of the internet, I grabbed this from lifearchitect.ai. I just want to show, like, when you're talking about ChatGPT and some of these platforms, where is all this stuff coming from? how are these platforms pulling all this information? How is this stuff set up? Well, ChatGPT 3 pulls stuff from these different data sets. You have all these different data sets. Okay, you have journals, books, Wikipedia, Google, the Wayback Machine. That's how a lot of people pull like these old websites that don't exist anymore. You can still pull information from these archives, and so that's where some of the AI platforms are pulling. You got Blogspot, GitHub, the New York Times, WordPress, Google Patents, and then a million more domains. So you have every different platform has their own data sets. Okay. And then they have some that are public, then they have some that are private. And so when you have AI platforms that are, that are proprietary, you may not know where some of this stuff is coming from. But now when you look at some of these platforms and it's querying, a lot of this stuff is showing you really quickly where it comes from. But I just wanted to give you an overview, like of a data set and how these things are pulling and where these things are pulling from. And this is ChatGPT 3. This is, just an overview of a data set and where these stuff is pulling information from. And so with this slide, I wanted to share other places. These are other places that are storing data that is being used from different platforms. Like look at the data set here. You got Slack, United States Patent and Trademark. When you talk about code, this is where all this stuff is coming. Government and legal, all these different wikis, 528 gigabytes. The web, academic papers. So like you talk about Google Gemini, you talk about all these different databases that house research papers, journals, all this information. Where's it pulling from? It's pulling from these resources you hear. The archive papers, PubMed, Slack, GitHub, Ubuntu. You see here, YouTube, books. I mean, it's a lot of different places. So I just wanted to show you. So you got educational resources, public domain stuff, online forums, academic papers, the web. So this is what I'm saying. And so if you have AIs that are generating biased research, then you could potentially have a platform that's pulling biased research from some of these journals. Okay. And then here we go. Where is the data coming from? That's why it's so important that we really, I guess, look at some of this information and understand where it's coming from. Any questions on this slide? All right, I'll continue. Now, this is the paper that I wanted to share that you guys can look up. How are we going to measure morality with an AI? Where in the world is this coming from? It's Microsoft. So this paper is the one that I found. It says probing the moral development of large language models through the defining issues test. And I've already went over that in the previous slide, but this is where when I looked at it, I was like, okay, this research is biased. Number one is because they did it for ChatGPT. Microsoft owns, I think, almost a little bit less than half of market share for ChatGPT. Okay, and so they're trying to use that the defining issues test to test morality, which I thought was very interesting in how they're trying to share that and put that information out. Okay, but what does that mean? What is the defining issues test? I talked about it a little bit, but it's basically 5 scenarios. Okay, involving real world ethical dilemmas. Okay, so after reading each scenario, the respondents answer the following types of questions. Like an action choice, a question asking like, what would the main character do? Should a person steal the drug to save his wife, or Not because of his some kind of moral posture about theft or whatever. Okay. Can they decide? Should they not decide? Okay. And then they rate the task. Okay. The participants rate a series of 12 statements representing different moral arguments based on the importance of making the decision using a scale from great importance to not important at all. Okay. And so with the defining issues test, which is a probability, um, they rank the top 4 most important items in a list of 12. Okay. So we're talking about focus areas, and they're testing whether a person prioritizes personal interest versus maintaining a norm versus post-conventional thinking. So when we're talking about personal interest, focusing on self-interest in personal relationships, or maintaining a norm, which is emphasis on legal, social, or religious rules. So post-conventional thinking is focusing on universal principles of justice. So like I said earlier, post-conventional thinking really just looks at how an adult would, would make a decision about something. Okay. And this is from Cambridge University Press in 2023, the Defining Issues Test. Okay. So you can check that out. Very interesting in how they're trying to validate political, religious, and different things. There's a lot of aspects that go into what humans do, and it's not just in some defining issues test. Okay. Because we are different. Okay. And so with that developmental progression, it made me take a deep dive into Kohlberg. Who is this guy Kohlberg? Kohlberg is this white guy from back in the day. Uh, he had a theory on the moral development, and Kohlberg's theory was that moral development progresses sequentially through stages. However, an important aspect to note is that this progression is not automatic or guaranteed. Factors influencing progression include cognitive development, your own social experiences, individual experiences, and opportunities for role taking and moral discourse. So Kohlberg's work emphasized on the importance of providing children with opportunities to engage in moral reasoning and decision making. This approach has significant implications for early years in education, encouraging educators to foster environments that promote moral growth, ethical thinking, and community decision making. So this was something that was used for kids to help to promote morality in kids in an educational setting. And so here we are in 2026. They're using Kohlberg's theory to create a defining issues test to say an AI is moral, which is incredible to me. But this is what's happening. Okay, this is what's happening. His name is Louis Kohlberg. You can check it out. And so when I was looking at this, I was like, there's a big limitation in this because it's looking at things out of context. So the neglect of cultural variation, we're all different. Okay. And so the theory does not fully account for how different cultural values shape moral development. For example, in a collectivistic culture, moral reasoning might prioritize group harmony over individual rights, a perspective not well represented in Kohlberg stages. Okay, so we're looking at a lot of different contexts here. You can't just look at one anecdotal moral theory from this guy and then push it forward in today's times for an AI. It's just not going to work. Okay, and so this is a big risk that I see when you're talking about the move towards super intelligence and things like that. But this is what's being applied, and this is what's being used to test some of these platforms. It's like a closed box, you know what I mean? And so when we talk about edge AI, and we're talking about, how close are these engines and how we're engulfed in these, and how you have thought experiments on some of these social media platforms, and you have all this stuff on your timeline, some things that is there because they're trying to perpetuate, growth spending for a company or some type of marketing analytic. Then we have to, take a step back and really look at what's happening on these platforms with AI. Now, open versus closed models in AI safety. So there's an ongoing debate: open models for innovation or closed models for safety and control. Like, what are we doing? So governments explore AI safety standards, testing, and reporting requirements. So that's kind of what's happening. The future ecosystem may depend on how openness versus risk is balanced in regulation. There is no regulation. It's like the Wild West. It's kind of like a race towards who has the best AI, and how can we use it to feed our agenda for whatever we're doing. Okay, so we have to really look at that and understand that regulation or some form of guardrails need to be applied when we talk about safety. I mean, we're already seeing now, like the recent thing about what is it? I think it's Facebook got caught up in a lawsuit, and it's really important. Creator economy and synthetic influencers. Now, this is another one that's really big with our youth, because our youth are really influenced by a lot of AI influencers or just people in general on social media. You have AI generated influencers and virtual characters are gaining huge and large audiences. And this stuff is so real that we can't even tell now what's real and what's fake. So what has happened? Brands are experimenting with synthetic spokespeople and fully generated campaigns where there's no real person involved. It's literally just AIs that are used in marketing campaigns. So media also covers concerns of authenticity, disclosure, and audience trust. Okay, so like if you could create a thought experiment for a particular demographic, and then you have an AI generate a virtual character, you can influence a lot of people to behave a certain way. And this is what's happening now. And so we have to really be aware and understand the creator economy and synthetic influence and some of the things that are happening now. And what's happening now? This is what's happening. So these images that you're looking at right here are some very, very popular, real virtual influencers. Okay. These are AIs that are not real, that have huge followings on the internet and social media. And so these are some of the examples that I'm talking about. And they can influence a lot of behavior because they're being pushed out at such a high rate. And they can influence a lot of people, as we're seeing now with some of the social media platforms. And they're hyper realistic, photorealistic. And this is just another image I want to throw out there about having an AI collaborator at your job. Okay, I think this is where we're going. We're looking at having a clone of yourself helping you do work. I could see this happening in the future. So it's very important in education. We got to reskill and create AI-ready talent. It's not about just being entertained by AI. Governments and firms highlight AI literacy as a foundational skill now. Okay, it's not just some big scary thing and we need to run away from it. We need to grab the bull by the horns, understand what it is. Upskilling programs emphasize data literacy, coding, prompt design. We know AI can create code, but we got to understand how to prompt them and how to recognize problems and understand complementary human skills with creativity and judgment and collaboration, and let those grow in value, because this is really important. Now, on this slide, I wanted to illustrate, for those of you who do use some of these platforms, you got to create a spec, especially if you're working on something. You don't want to just throw out a big ass prompt and run it, because an AI really doesn't work that way. You can have a lot of problems. So what I'm doing is trying to show you how to avoid some of the, I would say some of the hallucination, some of the errors, some of the problems. What you do is you specify what you want and why, and then you validate it. Okay. And then you plan, or you tell the AI, and what I'm saying here is you're telling the AI what to do and how to do it. So you say, okay, come up with a plan on how to build this for me. Okay. And then it'll kick out some information. And then you, as a human, you're validating that plan. All right. And then you say, okay, create some tasks or tell me what task that you're going to do. Okay. And then you validate those tasks and tell it to proceed. Okay. And then you implement, have it implement, execute, and then you verify. So these are some of the ways we can use AI to help us do things, okay, and help us um, avoid problems and risks, okay. And this was done. This is something that I grabbed from AI report.kd nuggets. This is somebody who actually worked at OpenAI to build the platforms, and so I just wanted to share that. So you want to do things in chunks, okay. You don't want to just, hey, upload a document, hey, do this. It's going to have problems. So you got to give it a specific plan or have it generate a plan based on what you uploaded or what you told it to do. Okay. So I wanted to share that with you. So you're just basically creating a specification for it to do something for you, for whatever it is you want to do. Now, in terms of software engineering and AI writing code and taking people out the loop, this is some of the serious stuff here, because software engineering, this is a graph that's showing which AI platform has the most accurate codes platform. And this is Opus 4.5 is done by Claude, and they say that it's about 80% accurate. And so Claude Code and OpenAI have graduated from autocomplete to project scale autonomy. Project scale autonomy is basically no human writing the code. It's just an AI doing it. Okay. And so what's happened is they ran a test, and Cursor documented agents running for 3 weeks, over 3 weeks straight, writing over 1 million lines of code on single projects. So basically, this is an AI that's running for over 3 weeks, creating something on its own. And one of the things that it did was it migrated an entire code base with about 266,000 additions and 193 deletions without any human intervention between the checkpoints. So basically, what this AI did for like a month on its own was build a project, fixing it, debugging it, fixing it, debugging it, migrating code, and just doing all these things on its own and creating some software. Okay, so you have AIs now that can write millions and millions of lines of code on its own. And so this is a graph breaking down Gemini, Pro 3, GPT-5, and Claude Opus 4.5. Okay, so I just want to share this with you guys, so you can kind of get some context and look at it at a different perspective when we're talking about just writing code to make things. This is kind of like a graph that I wanted to share. Also, this is from a developer who actually worked at OpenAI, who's kind of doing his own thing now. Concentration of power versus democratization. Top AI labs concentrate compute, data, and cutting edge talent. That's kind of what they're doing. At the same time, smaller and open models lower the barrier to entry. So there's a lot of big corporations making AIs, but guess what? You can make your own platform. It'll be smaller, and there's a lot of platforms that are doing a lot of cool things. A lot of them never see the light of day, or you've never heard of, because they don't have any marketing money. They don't have any marketing dollars, but they can do some very powerful things on the internet. And so the future may, in my opinion, may be a hybrid, where you have a powerful centralized model doing all these crazy things like Gemini, ChatGPT, and then you have a lot of local tools that do different specific things that you want. Okay, and so this is what I'm talking about concentration of power and democratization, which leads me to this slide. I don't know how many of you knew this, but Donald Trump did an executive order back in November 2025. It's called the Genesis Mission. And this is what it is. They're creating their own AI, the government. And so By the authority vested in me as president by the Constitution of Laws of the United States of America, it is hereby ordered, Section 1, purpose, from the founding of our republic, scientific discovery and technological innovation have driven American progress and prosperity. Today, America is in a race for global technology dominance in the development of artificial intelligence. Okay. And so there's something called the Genesis Mission. It's an executive order that what they're trying to do now is create their own AI. And this Genesis Mission involves all of the major partners. Okay. And what does it do? It creates some problems. Okay, when you think about it, implications and strategic questions I had were, where will sustainable value emerge as the government builds their own AI and hype cools? How will policy, chips, and talent pipelines shape competitive advantage? What mix of human skills and AI capabilities will your organization prioritize now? Because all of the major platforms out there are involved in this to make this AI. Okay, so this is a more detailed breakdown of what the Genesis Mission is and the executive order. So the Genesis Mission is a dedicated, coordinated national effort to unleash a new age of AI accelerated innovation and discovery that can solve the most challenging problems of this century. The Genesis Mission will build an integrated AI platform to harness federal scientific data sets, the world's largest collection of data sets developed over decades of federal investments to train scientific foundational models and create AI agents to test new hypotheses, automate research workflows, and accelerate scientific breakthroughs. The Genesis Mission will be viewed as the most forceful acceleration of 2025, combining 2026 generation of frontier AI models like ChatGPT, Claude 5, and Gemini 4 with exabytes of physical world data that will allow us to ask and answer significant questions across challenges like create a new and beneficial alternative to sugar, caffeine, alcohol, discover and harness a new near infinite energy source, cure specific forms of cancer and heart disease, discover an abundant new material to replace steel, aluminum, and concrete, optimize the way humans live aligned with UN rights. All right, now I'm going to pause here and open up the panel. And my first question to all of you is, how many of you are aware of the Genesis Mission right now? I'm just curious.
Not aware. I'm aware now.
Yeah.
And Ernest is unmuted now. Ernest, did you have a question for Mr. Hood?
Answered a lot of my questions, because I be arguing with my friends and stuff on sensitive topics like religion. And our challenge is, I say, because we don't really know if any of this stuff is true or who wrote it, and what was his mindset when he supposedly got it from a god or whatever, and he wrote it. But laying all that aside, what kind of piqued my interest the other day, because I live in the city of Lakewood. We got a population of 83,000 people. And they was talking about a data processing center that uses like 100 megabytes to run it, and 100 megabytes, can replace 80,000 people. So if they sucking up all this power, where is that coming from?
Yeah. It's definitely something
that's a concern, because we say we hurt is searching for power and stuff now. And then, you talking about one building going to suck up 80,000 people, needs of 80,000 neighbors, that use this energy. So that's kind of when I saw that kind of piqued my interest there. But yeah, but this is really interesting, and a lot of things that you were saying that I've always thought that too. What is the ethical part of this machine? And then what are you going after you replace all these workers? Because to me, the bottom line is they're about making money. It seems to be most companies they're interested in making money, so they put one of these buildings in your neighborhood, and then you talk about the pollution and stuff that it creates that's going to affect us, our future generations, and then we are. So you get rid of a bunch of people on the job, the human element, and you got the machines running and everything. Well, what happens to the human aspect? To me, it's really something to think about, to put on your mind. So that's kind of all I had to say.
Appreciate your comments.
You answered the question for me about the data inputs, because I'm kind of from the old school on computers, garbage in, garbage out. So you got to keep that in mind, So, an AIN don't mean, at the other end it's going to be beneficial, because it's going to be detrimental to a lot of us. And they don't seem to be answering that question. So that was kind of from the old timer standpoint.
Yeah, that's definitely an important topic. We have to keep our ears to the street on this. My understanding is, from looking at a lot of these platforms and large language models, is you can have an AI, a generative model that thinks for itself and generating new ideas and things. But as the AI learns more and gets more access to more data, the bigger they get, the more problems can be introduced because of so much data. And so you have to constantly massage things to make sure things are coming out right, because you can have all these little glitches and hiccups based on just how it was designed. So there's a constant monitoring with a human in the loop to make sure these things are kicking out accurate data. Okay. And so, yes, very important, very important. Anybody else had another comment or topic before I go into the AI designed drug nearing late stage trials? Okay, I'm going to continue. So this is the first AI totally generated drug that's nearing late stage trials. Okay, it's called rentosertib, and it's for idiopathic pulmonary fibrosis, which is called scarring of the lung. And went through a trial, phase 1, phase 2, and now it's gearing up to go through phase 3 trials. Okay, and so I wanted to talk about this because not a lot of emphasis being talked about in the mainstream about generative chemistry, which I think is really, really important, especially if all of a sudden we have these new drugs that are totally generated with AI introduced in the marketplace. What are some of the problems that can happen? Now, we know that there is no cure for pulmonary fibrosis, so there is a need for a cure for this. But what are the issues? Okay, so rentosertib is an AI-generated, first in its class small molecule being developed for IPF. AI was used for target discovery and prioritization and generative design of a small molecule. Leads lab plus clinical work followed standard practice. Okay, that's kind of what happened. And so we're talking about a real clinical trial. We're not talking about what happened with COVID, where they just kind of like shotgun through the clinical process and introduced to the market. This is a real clinical trial. You know, it used to be like 10 years before you introduce a drug to the market. But this is kind of like me going over a real clinical trial and looking at, man, this is a generative drug that was totally done with generative AI. So it's in a 71 patient phase 2 trial for 12 weeks, the 60 milligrams showed a 98% change uh, versus a negative 23 change in a placebo. So the next step is a longer trial to confirm efficacy and characterize it as safe or not. Okay, and so including liver-related events noted in phase 2. So what happened is I think they had 128 patients. 71 of them actually were accepted into the trial. Okay, and so um, there are new therapies that are needed in IPF. Okay, and so progressive scarring of the lung, worsening breathing, and cough. And the U.S. prevalence is about 10 to 60 people per 100,000 uh, have IPF, according to some research. And the median survival diagnosis was cited as about 2 to 4 years. So I'm not a doctor. This is just research for educational use. Uh, and what they're saying is if you have IPF diagnosis, they're saying that the survival rate is about 2 to 4 years. So there is a need. There is no cure. So the current standard of care for the decline of fibrosis, reversing fibrosis remains an unmet need. So this drug was generative, and it's the first one that's nearing phase 3 trials. And so the drug is called renticertib. Like I said, China is the country that introduced this. Here's some information about it if you want to research it. But phase 2, what they did was basically had 3 dosing regimens for 12 weeks. You had patients that took 30 milligrams once a day, 30 milligrams twice a day, and then 60 milligrams once a day. Okay, and so the primary readouts in phase 2 included safety and tolerability and lung function. So that's kind of what they did. They did a 12 weeks clinical trial on this drug that was totally created with generative AI. It identified, a regulator of IPF, which is scarring of the lung, um, you know, and looking at, pro-inflammatory cells and programs. And basically what they try to do is just to reduce the disease, to preserve normal lung function. And this is kind of a breakdown uh, of what the drug does. It identifies inflammation in the lung, and then rituximab inhibits that, and then the lung function will decline based on that, over time. But rituximab is just something that they're using to try to lessen the scarring of the lung. So that's kind of what this particular drug is for. And so this is how AI contributed to this trial. Okay. And we're talking about generative chemistry here right now. Okay. So you have the data, right? The AI basically looked at the data, the literature, all the health networks that are around this particular area, and then it ranked targets from evidence. Okay, and then what it did with generative chemistry is it proposed a molecule, and then you had lab validation using real chemists in the lab, and then you had the clinical trials. Okay, so what AI designed drug means here in plain language is AI accelerated early discovery promising as a promising fibrosis target and generating candidate chemical structures to inhibit it. Okay, so let me say that again. AI accelerated early discovery of a target candidate chemical structure. Okay, the candidate still required chemical synthesis, biological testing, toxicology testing, manufacturing, and conventional clinical trial. AI is just a tool in the pipeline, not a replacement for experimental validation or regulatory evidence. And so that's what we have to keep our ears to the street on with regulatory evidence. Because if we have, all these pharmaceutical companies, using generative AI to create all these new forms of drugs, what are the harmful effects? What are the things that are coming down the pike? What are some of the problems that could happen in the different demographics or targeted solutions on, introducing this to people without doing a real study? Okay, so what kind of study was this? This was called a randomized, double-blind, placebo-controlled study. That's really what you need for these drugs, and that's what used to take 10 years. Okay, we're talking about a randomized, double-blind study. And so at a glance, like I said, 71 people were enrolled, 22 sites in China were reported. They had a placebo. Then they did it for 12 weeks. Okay, and so it was basically looking at lung function. And so here's some more efficacy data, just kind of showing you. And yeah, they did have a placebo. And so this is kind of like a breakdown for those of you who are just kind of looking at graphs. This is just to illustrate some of that information. And then you have more information about the safety snapshot. There were some adverse effects. I guess some people had some liver issues. And so what needs to happen now is in the phase 3, more people and in a longer trial. Okay, so that's kind of what goes into a research, a clinical trial study. And so here's another illustration where it stands and what's next. AI accelerated early discovery. Late stage proof is still depends on the clinical outcome. So we have the early discovery, you have the lead generation, you have healthy volunteers who step up and say, hey, I want to participate. And then you have people who are, they're in the trial because they're sick. You have some patients who volunteer to participate because they've been diagnosed. Okay. So phase 3 is a longer study. Okay. And then you have regulatory review if things look successful. And so the key takeaway here is AI appears most impactful in the front end, which means and I'm talking specifically generative chemistry. AI appears most impactful in the front end with discovery and designing the molecule. Okay. So the clinical success still depends on phase 3. Okay. And so none of the AI discovered drugs have been completed in a phase 3 trial. Okay. So for decision makers, treat AI design as an acceleration claim, not as a clinical evidence in itself. Okay. So that's kind of what I wanted to put in there on that. So that's kind of my breakdown and takeaways of generative chemistry and the first AI designed drug that's in a clinical trial. And so for me, I wanted to show you guys just an illustration of what fibrosis looks like. This is a illustration of that. It's just basically scarring of the lung. And that's kind of what this drug was introduced to try to fight. So in 2025, generative AI moved from content into discovery, helping propose new drug candidates and new inorganic materials to test. So this next slide, these are some of the drugs that have been used in generative AI. Fibrosis drug, which I just talked about, a neuro drug, an oncology drug, antibiotics, new materials, and materials data sets. So these examples are research to clinical candidates. Not all are approved for medicines or commercial materials yet. Now, what I did here is I want to give you guys a breakdown. You know, like the periodic table of elements that you learned. Well, they've indexed and sequenced the periodic table to create new materials. Okay, and so this is a periodic style comparison grid. Each tile represents what it is, what AI contributed to it, what it's used for, and the maturity so far. Okay, so I said retentive, a fibrosis drug. AI designed a small molecule for IPF. That was in 2025. These results were published. Okay, now in 2020, there was a drug for I think it was an AI assistant drug discovery program for OCD. So there was a drug that was created with AI that never made it to phase 2, and that was back in 2020, and it's called DSP 1181. Okay, for OCD. The next one here on the right, EX, AI designed a A2A antagonist for tumors, solid tumor immunotherapy. Okay, clinical trial registered, but I don't think they completed that clinical trial for the oncology drug. And then you have an antibiotic drug that is a machine learning guided identification. So it's something called albosin, and that's an antibiotic. And it's preclinical right now, so they haven't went through a clinical trial for that antibiotic. Now, this next one, TACRO, is a new material, a generative material that's being used to create a new form of battery. They're trying to create new materials to create a battery, a new type of battery, to get off of some of the other materials that are, in the ground, but using generative AI to create inorganic candidates to create batteries. And then you have GM, which is the data set, the material. It's a platform that you use for generative material to create new materials. Okay, and so that's a data set. So I wanted to show that. Okay, so it's used for target discovery, molecule design, and property guided material generation. And so this is the actual retentive molecule for those of you, and that's the number. You can research that. But this is kind of what these generative chemistry platforms are doing. They're just generating molecules, and then the chemists would synthesize this stuff in the lab, and then they would move forward with that. So that's kind of what I wanted to do, that slide. Now, this is something that is just more of a breakdown of grid. You can kind of read that. I'm not going to read all of that, but it shows you the different generative stuff. So with retentive, generative AI help discover, target the pathway, link the design with the DP screening and optimization of the candidate, the antibiotic, machine learning compounds against different dangerous pathogens, and then you have generative AI proposed materials with mechanical properties. So there's a platform called MatterGen that researchers are using to create hard, high bulk materials. Okay. And then the GM, the genome generated crystal candidates. This is the one that's being used like deep learning crystal structures to make potential use in batteries, superconductors, energy materials. And so Google DeepMind reported about 2.2 million generated candidates, including about 38,000 stable materials. Now, these are just research candidates, not products yet. But this is where we're at. So we'll have generative AI creating new materials to make hard products, hard materials that are using MatterGen that includes an index sequence of a table of elements to create new things that have never been created before, like inorganic molecules and materials. So I just wanted to share that slide. And so what stands out here? What stands out for me is the biggest pattern is that AI is doing two different jobs now. In drug discovery, it is helping narrow chemical spaces for faster and move candidates like, retention and towards the clinic. In material science, systems like MatterGen and the genome are generating entire new inorganic candidates for batteries, hard materials, superconductors, and other advanced technologies. The second big point is that these examples are not all the same maturity level. Wintercertib is one of the strongest public examples because it has published mid-stage clinical data, while Abusin is still a research stage antibiotic discovery, and many AI-generated materials remain in candidate structures and still need synthesis and validation. The third point is that AI is not replacing chemistry or biology. It is acting more like a search and design accelerator, helping researchers explore huge spaces of possible molecules and crystal structures far faster than any brute force approaches. Okay, so we're talking about all these different things that are moving together at the same time. You have science materials being generated with AI, and then you have other aspects. So this is a breakdown for those of you who are into chemistry or may know somebody. This is what we go into making an AI generated battery material. Okay, where generative chemistry is producing promising hard material. We're talking about solid electrolytes, cathodes, electrolyte solvents, anodes, novel solid compounds. So this is what's happening in real time right now because of all this stuff that happened with MatterGen and then sequencing the table of elements. Okay, so you're looking at, fast screening, closed loop search. Okay, so AI is really, really coming forward with creating new materials, which is, I would say the biggest, the highest level of, technology and research. All right, so this is my works cited. I just wanted to share this with you guys so you guys can check it out. This is just where I got some of my research. You got all these, information from the Nature of Medicine. You got the Nature of Biotechnology, articles at nature.com, clinical trials from the U.S. National Library of Medicine. So all this stuff you can look up. It's all real world research. Google DeepMind, you can look at their paper on materials that they're discovering. AI agents, solid electrolyte chemistries. You have PubMed, all these different things here. Microsoft Azure, unlocking a new era for scientific discovery. How AI screened over 32 million candidates to find a better battery. That was in 2025. And then you can look at lifearchitect.ai for some of the statistics on some of these platforms, which is very interesting. And I wanted to share this slide. This brings me to the end of my presentation. And I did have something that I wanted to read, but this is how you can reach me. You can subscribe to my YouTube channel at youtube.com/BusTech Academy. And if you want to learn more about some of the other talks I've had about AI, just look at my AI Institute playlist on my YouTube channel. And that's my website there at bustechacademy.net. I will be updating that more in the future with some more information. And yeah, I want to stop the share on that. And I do want to read this. Okay, this is something that I wrote that I think is really important to close it out. The divide that will matter most in the coming years is not who has access to artificial intelligence, but who understands how to use it. We are living through a shift as significant as the arrival of the internet. Tools powered by large language models like ChatGPT, Claude, Gemini are no longer niche technologies. They are rapidly becoming the interface through which people write, code, research, design, and make decisions. To ignore them is not neutrality, it is falling behind. But using these tools casually is not enough. The real world advantage comes from understanding how they work and how to deploy them effectively. When you learn to work with large language models, you gain leverage. A single person can now do the work that once required entire teams drafting reports, analyzing data, building prototypes, even writing software. This is not about replacing human intelligence. It's about amplifying. Those who know how to guide these systems through precise prompting, structured thinking, and iteration turn AI into a force multiplier. Equally important is understanding their limitations. These systems are powerful, but they are not infallible. They can hallucinate, reflect biases, and produce confident but incorrect answers. Without working knowledge of how they generate responses, users risk outsourcing judgment itself. Learning how they function, at least conceptually, restores that judgment. It turns blind trust into informed oversight. Deployment is where knowledge becomes power. It's one thing to ask chatbot a question. It's another thing to integrate a large language model into a workflow, a business, or a product. So there is also a deeper reason this matters: participation. Technology shapes society, and those who understand it shapes its directions. If only a small group of people know how these systems work, then only a small group will decide how they're used. Learning large language models is not just a technical skill, it is a form of digital literacy and a civic engagement in an AI-driven world. The choice is simple. You can treat AI as a black box and remain dependent on those who understand it, or you can open that box, learn its patterns, and take control of how it serves you. And that concludes my presentation. Thanks for your time. And if anybody has any questions or comments, want to just add their own information, you guys have the floor.
Professor
Well
Rahh?
done.
No, I'm full.
I know it's a
Got
lot.
you.
It's a lot. I know it's a lot.
DX?
Mhm.
Yeah.
You there, DX?
Yeah, I was trying to unmute my phone. I
Oh,
mean, the
okay.
computer. Man, I think this is an excellent presentation and an awareness. This to go so levels deep, man. Like I got, I could just see how one little glitch in the AI imitating us, and it's trying to imitate society that doesn't have any morals. Where
Right.
are we getting the more? Where is it getting this moral code from? If everything we in a state of war right now, and uneasiness and stress and trauma, So if the
Yeah.
AI is utilizing like our social habits to conduct its own uh, allegory or research or however it wants to administer information, just like they have certain AI now that will like answer you in a language or in like your slang. Like you're like your AI will speak slang like you speak slang, or attempt to utilize like your like you was mentioning before how our habits become a part of the systematic algorithm per se. So they know what the outcome gonna be. When you get three people together and you do this, and this is gonna happen. So the computer taking that data and then formulating conclusions. I think this is a very, 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 very dangerous slope that we on. Even in grocery stores, you get in the automated line, it's like nobody getting paid but Walmart. We instead of
Yeah.
creating that continue the infrastructure where the public receives some benefit from what the corporations do. But I see us going into this colonial capitalism where once again it's the matrix and we're the energy perpetuating the machine like our own beast, like we're feeding our own beast. you know
Yeah,
that's all, man.
yeah,
Thank you so much.
DX, that's what I've been talking about. These things stay alive because people are utilizing it.
Yeah,
This
piggyback.
system thrives because we feed into it. So it's mind manipulation. A lot of it's mind manipulation, and that's where the issue becomes because you got the sheep. Most are like sheep, so you can't think for
Mhm.
themselves, so they just go along to get along. But yeah, Brother Hood, this is extraordinary information, and I see that not only are you teaching it, but you're mastering the information, and we need that. And so it's a I appreciate what you do because who do we know that does this but you?
Right.
Our platform. So it's an excellent thing, and we need to pay attention to what's being put out here. Like you said, we need to know how to
Definitely.
do some ground based things when it comes to this. And hey, if you don't
Yeah.
know nothing about it, you could be
Yeah.
victimized. But
Yeah.
we're gonna do our best. We're kind of a senior class right here, but we're doing our
Yeah.
best.
Right. Right. Exactly.
You and DX are the babies around here.
I hear you. I saw that brother. He had a question. Is he still online? He says, "What?" It says, "Why can't so solve that problem of efficiency?" I must have missed his question, but I guess he fell off
Yeah,
the panel. Yeah,
yeah,
but
because
He
it's
on,
real late. He's in
he's on the
Detroit,
East
so it's
Coast.
late. Yeah,
He's on the
okay,
East Coast.
okay,
yeah.
all right.
So yeah, appreciate it, Hood.
Oh yeah, yeah, most definitely, most definitely. And my final quote is what I tell a lot of people is, "Don't let AI operate in a space where your brain is supposed to think in." You know what I
You
mean?
said,
Yeah,
you
don't
said
let
don't let them
AI.
replace you. You
Yeah,
be
don't
the
let AI.
engine.
Yeah, don't let
And
AI
what I'm
operate in this.
taking from it,
Yeah,
whenever you feed it, you regulate it. From what
exactly.
you saying,
Yeah,
yeah,
you got to
go
do that.
back and regulate and see what
Yeah,
it's doing, and you be the driver of it. Just let it
yeah,
help you. That's all.
exactly. It's a collaborator.
Yeah,
Yeah, definitely,
yeah.
definitely.
Without having a bot sit next to you though.
Right, right, right. Exactly, exactly.
All right,
All
Professor
right.
Rod, you got anything going on next week?
I'll call you tomorrow. I got to verify.
Okay, well,
I'll verify.
nothing's going on. If something's going on Wednesday of next week, it's going to be on the website, but I don't think so. That
I,
this so
I,
we have
I know
we have
I'm going to be there next week no matter what, but I'm trying to
yeah,
get the guest speaker, special guest, Brother
okay,
Akili, Black Lives Matter.
okay, well, good. All right,
All right.
all right, good folks.
All right.
Mhm.
Appreciate it. Each one teach one in Conscious Corner. We're gonna stay up on the AI, people. We're gonna stay up on it because we
Yeah.
got Hood. Hood,
All
don't you
right.
go nowhere. 'Cause we
All right. Y'all take care,
Thank
man.
you,
Good
bro, for
seeing y'all,
got
man.
yeah.
AI
Yeah.
teaching. All
Definitely.
Thank
right,
you.
brother DX.
All right.
Thank you.
Take